Hello, welcome back to our channel. I am Anisha, your maths faculty for class 12th. Okay, we have started our chapter 5 in this chapter, continuity and differentiability, and in this chapter we have started exercise 5.1, and we have did the question till question 9, yeah, or till question 9. Now we proceed to the further questions. In this video, we will do question number 10 and 11. Okay, let's begin our questions. Before that, I will just ask you if you have doubt in the previous questions, please comment in. Please comment. I will like resolve your questions as soon as possible. Now let's do question number 10. Okay, what we have to do in question number 10, find all the points of discontinuities of f where f is defined by. Okay, this is our function and we have to find all the possible discontinuity points. Okay, we know that if you have a function like this in which your function is just dividing in different functions at a particular point, then always you have to do what you have to do. You have to always just divide it in cases. Case before that point, case 2 after that point, then case 3 at that particular point. Let's begin. So our case 1 will be point when our x is strictly greater than 1. Okay, whenever x is strictly greater than 1, take our x as a, some a, where a is just like it's strictly greater than 1. So to check its continuity, what we have to do? We always have to find its function value and we have to find its limit value. As you can see, for each and every point in the domain, the function is defined, and here our domain is R, right, whole real, because function is defined for each and every point in the real number. So for each x, like we have just started with any like a greater than 1. So we will check its continuity. So for that, first we find our function value. For greater than 1, our function is defined as x plus 1. So this will be a plus 1. So now let's find its limit value. So this will be limit x tends to a f of x. For x greater than 1, we know that its function value is defined as x plus 1. So now this limit will be nothing but a plus 1. Now as you can see, our function value and the limit value is same. So from here what we get? Our f is continuous at x equals to a. Now we have just taken any arbitrary a which is greater than 1. So from here what we get? Like it's this a can be 1, this a can be sorry, not 1, it's greater than 1. So this can be 2, this can be 3, this can be 2.5 also, this can be 5 by 2, 5 by 3 also, like any real greater than 1, because we have just started with any arbitrary, like we have just named it as a variable. We didn't take any fixed value, but what we have taken the condition that it must be greater than 1. So from here what we get? Our f is continuous for any x greater than 1. Okay, then in this our case 1 is done. Now case 2. Case 2, we have to check the continuity when our x is strictly less than 1. So here also we have to do the same thing. First we have just started with any just this will be like for you guys. Try by yourself. Right. I will tell you the answer, and it's just same as we did in the case 1. But only the case is you have to take x less than 1, and your function for this time will be x square plus 1 instead of x plus 1. So for that, just find your function value, find your limit value, and you will come to know that this will be same. So from here also you will get your f is continuous at any x less than 1. Now we are left with the case 3. What is the case 3? I just tell you, when you have only one point where the function is just dividing. So our case 3 when our x is exactly equals to 1. So for this our function value, so our f of 1, as you can see, our f of 1 is defined as for 1 it is defined as x plus 1. So this will be 1 plus 1, which is nothing but 2. Now limit value. So limit value, we have to find limit x tends to 1 f of x. Now as you can see, for x greater than 1 it is defined as x plus 1, and for x less than 1 it is defined as the different function. So what we do is we will find its limit by using the left hand limit. All if you have a situation that it is defined that see this is our x equals to 1, for left hand it is defined another function that is x square plus 1. For here for right hand it is defined as another function that is x plus 1. Whenever you have a situation like this, always find your limit by using like find your left hand limit, then find your right hand limit, then just conclude about the limit. So first we will find for the limit. For this, we will first find our left hand limit. So this will be limit of x tends to 1 minus. Here our function is defined as x square plus 1. Let me confirm if I didn't make mistake. Yeah, it's true. For x less than 1, it is defined as x square plus 1. So this will be 1 square plus 1, which is nothing but 2. Now its right hand limit. Right hand limit. So its right hand limit will be limit of x tends to 1 positive. Here our function is defined as x plus 1. So this will be 1 plus 1, which is nothing but 2. So what you get? Your left hand limit is equals to your right hand limit. So, and we know that this is nothing but 2. And this is nothing but equals to our function value. So what you get? Your left hand limit is equals to your right hand limit, and which is nothing but 2. And your limit value is equals to our function value. So now what from here what we have concluded that our function f is continuous at x equals to 1. So as you can see in all three cases what we get that the function is continuous at each and every point of a real number. So what will be our conclusion that and what we have to find? We have to find that where the function is discontinuous and from case 1 that it is continuous for every x greater than 1 and case 2 it is continuous for every x less than 1 and we have also find that it is continuous at x equals to 1 also. So what will be the conclusion that f is continuous for any x belongs to domain that is nothing but our whole R. That means there is no point of discontinuities. Okay, so we are done with this our question number 10. Now let's move to the next question. Okay. Now the next question is question number 11. Here also we have to do the same thing. We have to find the number of not number, the point of discontinuities of this function f. So our f is defined like this. Now we have to find the point of discontinuities on it. Okay. Here also function is like divided for less than 2 it is some another function, for greater than 2 it is some another function. You like it's just same as we have did in the question number 10. Just like function is changed, now everything is fine. Boards also you have a question like this, like you will ask the same question but like find all point of discontinuities, or in place of all points they can ask number of points of discontinuities. Just the thing you have to do is the same thing, find the discontinuous points of all the functions, like all discontinuous point of that function. Okay, so let's begin for this. So take the case one. I guess just very easy. Case 1. Whenever x is strictly less than 0, here our function is defined as x cubed minus 3. So first of all, let's take any x equals to a which is less than 2. Okay, for this case. So here our f of a will be defined as a cubed minus 3. Okay, now if we find its limit value, so limit of x tends to a, here the x cubed minus 3, so this will be a cubed minus 3. As you can see, function value is same as limit value. So from here what we get, our f is continuous at x equals to a, and we have started with an any arbitrary a which is less than 2. That means we have started with any a less than 2 and we have find that for that point a the function is continuous. So as it is an any a, so from here what we get, f is continuous for any x less than 2. Similarly, we will move to the case 2. What will be the case 2 here? So case 2, when our x is greater than 0, we have to do the same thing, just take an arbitrary b instead, like for like if you don't want any confusion, just start with any arbitrary b, check its function value, check its limit value. If they are same, then you will just find that the function will be continuous at that point b, and as you have started with the like b is arbitrary, so the same procedure, like this whole same thing you have to do in this case. So I will leave you for this for you. This is just for you guys. Like it's very easy. So from here also we will get that f is continuous at x equals to a for any. a less than, sorry, here the case is greater than 2. For any a greater than 2. So from here what we get, f is continuous for any x greater than 2. Now we are left with the case 3. Okay, case 3, whenever x is equals to 2, right? So, okay, case 3. Case 3, whenever x is exactly equals to 2. So for that, first we find our function value. So function for equals to 2, it is defined as x cube minus 3. So this will be 2 cube minus 3. That means 8 minus 3. That is nothing but 5. The function value is 5. 5. Now let's find its limit value. That means limit x tends to 2 f of x. Now see, as our function is like defined different for different, when you are approaching from the left hand side, like the same thing we have did in the question number 2. So for x equals to 2, if you like approaching from the left hand side, you have different function. If you're approaching from the right hand side, you have the different function. From right hand side, you have the function x square plus 1. And from left hand side, you have the function x cube minus 3. Now let's find, so to find its limit, we will find by using the left hand limit and right hand limit. So left hand limit will be limit of x tends to 2 minus, the function value is x cube minus 3. So this will be 2 cube minus 3, that is nothing but 5. Our left hand limit is 5. Now right hand limit. So right hand limit will be limit of x tends to 2 positive. Your function is defined as here x square plus 1. So this will be 2 square plus 1, and this is nothing but 5. As you can see, left hand limit will be is equals to our right hand limit, and which is nothing but 5. So from here what we get, the limit of the function is nothing but 5. As you can see, the function value is also 5, limit value is also 5. From here what we get, f is continuous at x equals to 2 also. So what will be the conclusion? That the function, this function f is continuous at each and every case, because like it's continuous at each and every case. From here what we get, the function is continuous at each and every point in its domain. So from here what will be our conclusion? Let's make our conclusion. So our conclusion will be, always make your conclusion clear. Okay, so conclusion is f is continuous for given any, I will write in for any x in the domain. Here our domain is nothing but R, or in another words, that is f don't have any discontinuous points, do not have any point of discontinuity. Okay, now we have done this. That's all for this video. We have completed the question number 10 and 11 for exercise 5.1. That's the motto of this video. I hope you guys like this video. Please do once this question by yourself. If you have any doubts, then just ask your doubt in the comment section. I will reach out to you by this comments, and I will solve your doubts as soon as possible. Till then, goodbye. Please like, share, and subscribe.